Hello everyone, my name is Zishan. You're welcome to Zishan classes, and today we are going to look at another question from Kinematics. In the previous video we solved a question which was very interesting from the same chapter. Now we're going to go ahead with another one. So the problem is that there's a small body which has been launched up an inclined plane, the angle of which is 15 degree. We have to find the coefficient of friction between the block and the inclined plane. The condition that is given to us is that the time of ascent and the time of descent are in the ratio 1:2, or it's said in the question that the time of ascent is 2 times less than the time of descent. The time of ascent is 2 times less than the time of descent, which obviously means that TA by TD is equal to 1/2, and we have to find the coefficient of friction. So first we are going to analyze the ascent of the block, and then we'll go to descent, keeping in mind the condition given to us. So the key to the problem is you need to understand the direction of friction acting on the body when it goes up and when it comes down. So when the body goes up, the friction acts downwards. The friction acts downwards. And what are the other forces acting on the body? We have mg cos of alpha. Let us name this angle alpha. Mg sin of alpha, and the reaction and the friction acting on it, mu r. These are the forces acting on the body when the body is going up. When the body is going up. This is discussing about ascent. Okay. Now, what are the equations going to look like for this body? What are the equations going to look like for this body? If we want to calculate the acceleration of the body, we are going to use F equals to ma. This implies that minus of mg sin alpha plus mu r is equal to ma. This implies that minus of mg sin alpha plus mu times mg cos alpha equals ma, which gives us acceleration is equal to minus of g sin alpha plus mu g cos of alpha. See, I am ignoring the basic knowledge of r being equal to mg cos alpha. The reason why I am ignoring it, because it's quite evident here that r and mg cos alpha are the same, because there is no motion of the body in that direction. In this direction, these two forces must be equal. That is why I have replaced r with mg cos alpha. And people may ask me, why have I used the value of the limiting friction? The reason why I have used limiting friction is because the body is in motion. The friction has reached its limit. That is why we have used mu r here. Rest. You can also ask why the acceleration is negative here. Yes, the acceleration is negative because the body is moving up the plane and there is retarding force acting on it. The retardation is what we are getting at with the negative sign. So we will keep this aside with us. Acceleration is equal to minus g sin of alpha plus mu g cos of alpha. We will calculate the value of the initial velocity. V is equal to u plus at, which gives us 0 equals u minus of g sin alpha plus mu g cos of alpha times t. Why have I written v is equal to 0? This is because the final velocity of the body is obviously equal to 0. Initial velocity we have no idea about. this gives us u equals g sine alpha plus mu g cos of alpha times t. Also, we can use v square minus u square equals 2as, which will give us 0 minus u square equals 2 times minus of g sine alpha plus mu g cos of alpha times s. U we already know the value of. We can put u here, which will give us g sine of alpha plus mu g cos of alpha times t whole square divided by 2 times minus of minus g sine alpha plus mu g cos alpha equals s. What have I done here? U I have put the value of from here, this factor 2 times this much till here I have put down in the denominator. What this helps us to do is find the value of s. I want you to write these two down and then we'll go ahead with the problem. Till here you can write and then we'll get the value of s. I'm gonna erase this now. S we will get, s will be equal to g sine alpha plus mu g cos of alpha times t square whole divided by 2. Keep in mind that this is the time of, this time here is the time of ascent. So we are going to put a subscript here of a just to keep it clear. So the distance traveled by the block s will be equal to this much times ta square divided by 2. Okay. Now let us quickly get to descent and discuss the factors there. We will talk about descent. See, the only thing that changes here with descent is the direction of friction, which was earlier that way, it's going to be that way, mu r. Also this arrow needs to be pointing this way. Now the change of direction of friction, what is it going to, how is it going to affect our value of s here? If we follow the same pattern to reach s in the time of descent, we will get at s in this case will be equal to g sine alpha minus mu g cos of alpha whole divided by 2 times t d square. We will name these two equation number 1, equation number 2. I hope you can get to s equal to this much. Following the same pattern, just keep in mind that velocity, final velocity and initial velocity, you will see that the final velocity is not 0 at the time of descent and initial velocity is 0 at the time of descent. So keeping these things in mind, you can get to the value of s following the same pattern I did for s equals to this much. So what we will do is we'll simply divide these two equations to, why am I dividing these two? Because s, the distance traveled in both the cases at the time of descent and ascent is the same. So we will divide these two. Dividing 1 by 2, dividing first equation by the second equation. we get g sine alpha plus mu g cos of alpha divided by g sine of alpha minus mu g cos of alpha times ta square times td square equal to 1. Please note this down. This is the time of descent, this is the time of ascent. Okay. Taking this up, what we'll get at is ta square divided by td square will be equal to g sine of alpha minus mu g cos of alpha divided by g sine of alpha plus mu g cos of alpha. Now, please note everything down that I am writing on the whiteboard. This implies that Ta divided by Td, we already know that Ta by Td has the ratio of 1 by 2. This implies that 1 by 2 square equal to 1 by 4 equal to g sine of alpha. We can also quickly divide the numerator and the denominator both by cos of alpha and also take g common out, so g cancels from both denominator and numerator. This turns into tan of alpha minus mu divided by tan of alpha plus mu. So we have arrived at 1 by 4 is equal to tan alpha minus mu divided by tan alpha plus mu. Okay, so all we need to do is solve this for mu. Solving this for mu, we will cross multiply. Tan alpha plus mu equals 4 tan alpha minus 4 mu, which gives us 3 tan alpha equals 5 mu, which gives us mu is equal to 3 tan alpha divided by 5. We had to find the coefficient of friction and we have arrived at coefficient of friction is equal to 3 tan of alpha divided by 5. Now simply put the value of alpha is equal to 15 degree in this equation and you'll get the value of mu. That's it. So the key to the problem was realizing that the friction changes its direction. That direction actually converts into a negative or a positive sign in the equation of analysis of velocity, distance, time and other things. That's it. That's all for this question. There's nothing else required. So I'll meet you in the next question. You have a good day. Bye.